we are going to graph the cosine function in this problem. So if you recall it, the ordered pair around the circle includes cosine as its x values. So we are going to get started looking at our x values, and again we'll start with 0, so we are going to go to the positive direction. So we start right here. So at 0 our cosine value is 1. Then at pi over 4 our cosine value is root 2 over 2. At pi over 2 our cosine value is going to be 0. At pi or 3 pi over 4 our cosine value is going to be negative root 2 over 2. And then at pi we are going to have, which is right here, we are going to have a cosine value of negative 1. And the next one is 5 pi over 4. So 5 pi over 4 is here, cosine value of negative root 2 over 2. 3 pi over 2, which is here, the cosine value is 0. 7 pi over 4 is here, the cosine value is root 2 over 2. And at 2 pi we arrive at the 0 line again, so at 2 pi our cosine value is 1. And if we pass that by a pi over 4, again our cosine value is going to be root 2 over 2. So let us fill in this information into our table of values. So we are going to say at 0 our cosine value is 1. Pi over 2 is root 2 over 2, or pi over 4, sorry, is root 2 over 2. And at pi over 2 we have 0. 3 pi over 4 we are going to have negative root 2 over 2. And at pi we are going to have negative 1. 5 pi over 4 we have negative root 2 over 2. 3 pi over 2 we have 0. 7 pi over 4 we have root 2 over 2. And at 2 pi we have 1. And if we move back to 9 pi over 4, which is reference angle of pi over 4, we get root 2 over 2. Now we are moving in the negative direction. So starting from 0, we are going to go to pi over 4, negative pi over 4, which is 7 pi over 4. So it's root 2 over 2. So I'm going to write that. And then we keep moving. So the next one is going to be negative pi over 2. So the cosine value is 0. Then we move again to negative 3 pi over 4. So our cosine value is negative root 2 over 2. Then we are going to move to negative pi, which is right here. So our cosine value is negative 1. So from there we are moving to negative 5 pi over 4, cosine value negative root 2 over 2. Then we are going to negative 3 pi over 2, cosine value of 0. Then we are moving to negative 7 pi over 4, which is root 2 over 2. And at negative 2 pi we are arriving at the 0 line again, so our cosine value is going to be 1. As you remember, root 2 over 2 is approximately 0.71, and negative root 2 over 2 is approximately negative 0.71. So let's go ahead and graph our cosine graph. Again, I'm going to start with 0. So at 0 we have 1, and we are going to the positive direction. So at pi over 4 we have 0.7, and then we have 0. Then we have negative 0.7, then we have -1, -0.7 again, then 0, then 0.7. It's a little bit too high, so I'm going to move that down a little bit. So that's going to be 0.7, then we'll go to 1, back to 0.7, and back to 0. Now we are moving towards the negative direction, so I'm going to start again from 0, 1. So it's √2/2, which is 0.7. Then we move to 0. Then we move to -0.7. Then -1, -0.7, 0. Then we move to 0.7, and then we move to 1. So now we are going to connect these points to create our y equals cosine of x graph. So make sure you're connecting with a nice curve. And put your arrows at the end of the two ends of the graph, because you know that the domain is going to be all real numbers. So let's go ahead and write that down. Domain is all real numbers. And the range for the graph is going to be y is greater than or equal to -1 and less than or equal to 1. So now we'll need to answer a few questions. We need to identify the x-intercepts, and then we need to find the x values where the local minimums and maximums occur. We need to find the intervals for which the function is increasing or decreasing over x is between -2 pi and 2 pi. And then we also need to identify if the function is even, odd, or neither. So let us start with the x-intercepts. So our first x-intercept is -3 pi over 2 and 0. Our second x-intercept is -pi over 2 and 0. And then we'll have pi over 2 and 0. And then we'll have 3 pi over 2 and 0. So let's list these. So our zeros or x-intercepts are going to be -3 pi over 2, 0, -pi over 2, 0, and pi over 2, 0, and the last one is 3 pi over 2, 0. Then we are going to find our minimums. So let's go ahead and find our minimums as ordered pairs. So our first minimum occurs at -pi, so -pi and -1. Our second minimum occurs at pi and -1. Now let's find our maximums. So our maximums occur at -2 pi and 1, and the next one is at 0 and 1, and then the last one in this graph is at 2 pi and 1. From here we are going to look at where the function is increasing and decreasing. So let's look at increasing. So our function is increasing from here to here. So it's increasing on the interval of open parentheses, which is -pi to 0. And then it's also increasing from pi all the way to 2 pi. So pi to 2 pi. And again, I'm doing this in interval notation. So then we are going to look at where the function is decreasing. So let's look at a different color for where it's decreasing. So decreasing. So the function is decreasing starting from negative 2 pi all the way to negative pi. So negative 2 pi to negative pi. And it's also decreasing from 0 to pi. And the last thing we need to figure out if the function is odd, even, or neither. Remember, if f of negative x is the same as f of x, then the function is going to be even. If f of negative x is equal to negative f of x, then the function is going to be odd. And the function is neither if it's neither of these two. So let's look at if I substitute in the same function value of positive and negative. So if I substitute in, for example, pi, I will get negative 1. If I substitute negative pi, I will also get negative 1. So that means our function is going to be even. So the y equals cosine of x function is even. So I'm going to box this in, and we just graphed our first cosine function. The general form of the equation of a sine x is going to be f of x equals a times sine bx. You have seen that in the previous part of the lesson. And so if we are going to look at a times sine bx, a is going to tell us our amplitude. So the amplitude in this case is going to be a equals 4. And since b, the value of b is 1, to calculate the period, we are going to have to do 2 pi divided by b. Since rb is 1, we are going to do 2 pi divided by 1. So the period is just going to be 2 pi. So here I am going to say b was 1. And the last thing we need to answer is the transformation. So the transformation is a vertical stretch by a scale factor of 4. So I'm going to start graphing by making a unit circle, and I'm going to also first graph the parent function and then graph the transform function. So the reason why I made the unit circle, because when I'm graphing the sine graph, I'm not going to use all those points that we had plotted on the first graph that we made to see the shape of the graph. I'm only going to use 4 values. So we know that at 0 degrees, the order pair is going to be 1, 0. And this is 0 degrees, right, or 0 radian. And we also know that the y-coordinate is our sine value, so that's what I'm concerned with. My second order pair that I'm going to graph is my pi over 2 radians, or 90 degrees. Here we have 0, 1 as an order pair. My next order pair that I will graph is my pi radian, or 180 degrees. And here the order pair is negative 1, 0. And last, I am going to graph my 270 degrees, or 3 pi over 2 radians. And the order pair here is 0, negative 1. And last, I'm going to end on 2 pi, which is going to be the same as 0 radian. So when I'm creating my table of values, x will go here, f of x, which will represent my parent function of y equals sine x. And then I am going to have g of x down here, which will be the transformed graph. So let's go ahead and write in the values for f of x. So in the center of the table, I will put my 0. And as I said on the unit circle, I'm going to start with 0, pi over 2 pi, 3 pi over 2, and 2 pi. So those will be my x values. So pi over 2, pi, 3 pi over 2, and 2 pi. Then in the negative direction, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So when I look through the unit circle, at 0, my y coordinate is going to be 0. So that's what I'll write. And at pi over 2, my y coordinate, which is my sine value, is 1. Let me go ahead and do that in black. And then at pi, my sine value is 0. And at 3 pi over 2, my sine value is negative 1. And at 2 pi, we arrive back at 0. So if we go in the negative direction, then we'll go this way. So from 0, we go to negative pi over 2, which is negative 1, and so on. So negative 1, 0, 1, and 0. I'm going to label my graph or my coordinate plane. So here is our point, that is our 0, 0. Here is my 1, 2, 3, 4, and negative 1, negative 2, negative 3, and negative 4. 2 squares for me will represent pi over 2. So that's pi, 3 pi over 2, and 2 pi. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So it's up to you how you would like to label your x-axis. I kind of like to go 1 square to be pi over 4. However, oftentimes when the period changes, I will have to change the x-axis. Currently, since we have a period of 2 pi, I don't have to do that. So now I'm going to start graphing from 0, 0. So here's my first point. Then at pi over 2, I have 1. Then back to 0, negative 1, and 1. And then I go in the negative direction, which is negative 1, 0, 1, and negative 1. So now connect these points with a nice curve. So you could have your sine graph. This is your parent graph. So we are going to label this f of x equals sine of x. And then we are going to graph our g of x, which has a vertical stretch of 4. So I multiply every y coordinate by 4. So we start graphing from 0, 0. So our point at 0, 0 is 0. Then the next point at pi over 2 is 4. Then back to 0. Then go to negative 4 and 0. And then go the other direction. So negative pi over 2 is negative 4. Back to 0, 4, and 0. So again, connect this with a nice curve. Connect the points with a nice curve. And we just did a vertical stretch by a scale factor of 4 on the y equals sine of x graph.